Welcome back. This is Mr. Greenstein's geometry class, and we're going into section 3.2, parallel lines and transversals. We're going to talk about that right now. So we have some theorems that we have to cover. The first one is corresponding angles theorem. So corresponding angles, as you recall, are on the same side of transversal, and they happen to be like on the north side of the two lines that they're intersecting with. So 2 and 6, 1 and 5, or they could be on the south side. So they could be like 4 and they could be 8, like that. So in the diagram, we could say that those are the corresponding angles. And the theorem says if two parallel lines are cut by a transversal. So we always start out with that we have two lines that are parallel, and in this case P and Q. If that's true, then the pairs of corresponding angles, meaning like we'll pick a pair 2 and 6, then they are congruent. So in the diagram, 2 is congruent to 6, 3 is congruent to 7, 1 is congruent to 5, 8 is congruent to 4, 7 is congruent to 3. So we have lots of corresponding angles going on. The alternate interior angles theorem is talking about like 6 and 3. They're interior because they're in between P and Q, and they alternate on either side of the transversal. So 3 and 6. If two parallel lines are cut by a transversal, notice that this line starts out with two parallel lines are cut by a transversal. The same thing was said in this other one. Two parallel lines are cut by a transversal. So we start out exactly the same way. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So 3, we'll go back to 3 and 6, they're alternate interior, so they are congruent. 4 on this side and 5 are also congruent. So 4 and 5, 3 and 6, and those are the only two pairs for alternate interior. Now let's go to the next one. Alternate exteriors. So now we go to the outside. So 2 here, and then down here 7. 7, and then 2 up here. So we're going to start out with the same line if two parallel lines are cut by a transversal. So we always start out with that fact. And then we say that the pairs of alternate exterior angles are congruent. So that means that 2 and 7 are going to be congruent. Likewise, 1 and 8 are going to be congruent in this particular diagram. So now we have three theorems. We have the corresponding angles theorem, we have the alternate interior angles theorem, and we have the alternate exterior. Now there's one more, and that one is called the consecutive or same side interior angles theorem. So in this particular case, same side would be like 3 and 5, and they're interior. So they're interior to the P and the Q. So consecutive interior angles, if two parallel lines are cut by a transversal, once again we start out with that phrase. So let's just highlight that. Then the pairs of consecutive same-side interior angles are supplementary. Supplementary, that means that angles like 3 and 5 are going to be supplementary or 180 degrees when we add them up. The same thing can be said about 4 and 6. When we add 4 and 6, we will get 180 degrees. So there are our four theorems for parallel lines. If you have parallel lines, then these angles will be either congruent or In the case of the consecutive interiors, they're going to be supplementary. So you're going to solve using the parallel line theorems, determine all the angles using the postulates and theorems we learned, and you're going to determine all the value of x. So go to my slides that are online and look these up, and you can work on these problems, or you can stop the video at this point and work on these. Then I want you to prove the alternate interior angles theorem. So we start out with just the fact that we have two lines that are parallel and they're cut by a transversal. Plus, since we have in the diagram's always given, we have angles 1, 2, and 3. So we can say something about that. Now, just to give you a little clue here, notice that 2 and 3 are vertical angles. So that is a little clue there as to how to solve this problem. So why don't you work on that one, and you can stop the tape here, and then there's your homework. So that concludes section 3.2.